Okay, so we're gonna start. If you have any questions along the way, feel free to either type them in the chat or, just turn on your mic and talk. It's okay. You can interrupt me. It's gonna be pretty relaxing workshop. It's just gonna be all basic review of, the basic concepts that you guys talked about in the class. So it's basically just gonna be an introduction to Java programming and basically all the things that come with that. So my name is Alec, and I am one of the lead computer science tutors, and I'm a senior. It's my last semester, so it's very exciting. So what we're going to be talking about today is that we're just going to give a brief overall introduction to Java and how to set up a Java program, talk about if and switch statements, loops, taking user input, arrays, classes and function, and then there'll be time for Q&A at the end of the presentation. So you guys can ask any more specific questions at that point, and I can even open up a Java compiler and code on there as well if you guys want to see some of that. So before we start, going over the basics of Java, we have to first figure out, what is Java and what is it used for? So basically the definition of Java, that it is a general purpose programming language that is class-based, object-oriented, and designed to have as few implementation dependencies as possible. So what Java is mostly used for nowadays is software development, mobile applications, large system development, and it's actually the most commonly used programming language currently. And I think by quite a bit margin too. I think the second most popular one is C++, which you guys, if you are a CS major or a CSE major, you guys will learn in CSE 240, which is about probably 2 or 3 semesters away. So the very first thing that we need to do is setting up an executable Java file. So most of the time, the structure is going to look exactly the same. So you guys probably have seen the code on the left like hundreds of times with all your programs so far. So we're just going to talk about the general structure. So we know that first we need to make the class that we're going to be running. So it normally follows the syntax of public class, and then the name right there, like the hello world in this case, is the same name that your file's named. So you can assume that this file's name is hello world. So that class must match the file name. And then inside of it, public static void main string args. You've probably seen that 100 times as well. Pretty much every program is going to have that. Actually, every program in Java is going to have that. And the main function is pretty much always going to follow that syntax. And if you guys don't quite know what all those words mean, like public, static, void, and then the strings with the brackets and all that, we'll be basically going over pretty much everything on that later on in the slides. So, yeah, so this will be uploaded to YouTube channel. Here's the link for that right there. For anybody that joined more recently, that is our YouTube channel. It will be uploaded to that channel after a couple days after it's been all edited. So the one thing to remember is that pretty much anytime we're going to be running a program, that it needs to have a main function. If there is no main function, the program's not going to run because the main function is always where the code starts. So anytime you click the run button, it'll actually jump to the first line of the main function. So like in this case, it would be like line 4, but there's no command there besides a comment. So it would do line 5 first. So I would hit run on this program. It would just print out hello world. So keep in mind that, a program can have multiple files, but only one of them can have main. If you have multiple main files in one project, it won't, like when you click run, it won't know which one to run first. Because remember, the main function is always the first function ran. So if you have 2 of them, it won't know which one to run. So it'll give you some errors. So make sure if you have multiple files that only one of them has main. So now we're going to go over basic variable syntax. So right here is basically how it's always going to follow this general structure. Let me change the color from yellow. I don't know why it's yellow. So we're going to follow this basic syntax right here. It goes like the type. So like int, double, string, char, boolean, and there's a lot more that you guys will learn as well. So, and then you just name your variable. So in this case, it's like, X, Y, name, letter, Z, and the name doesn't matter. But for the most part, you want to name it something that like makes sense. Because think about it, if I just name a variable X and I use X everywhere, and I come back to the program, let's say like 2 weeks later, I might completely forget what X does. So a lot of good coding practice is to name your variables like based on like what they're going to be used for, and then that will help you remember like if you ever come back to your code, like what that variable does without having to like trace back. And then we have the equal sign and then the value. So the value depends on the type. So like in this case, we have int, and so that the number, so the thing after the equal sign has to be an integer. And an integer is just basically like a whole number, anything without a decimal. So like 1, 2, 3, 4, any negative numbers, it just can't have like a decimal after it. That's an integer. A double is like the counterpart of that. It's pretty much only decimals. And it counts like 2.0 as like a decimal. So like a double is basically anything like 2.1, 2.2, 3.45, pretty much anything that has a decimal. String is any, I guess, it's basically words, or it can be a single letter too. It's just basically a string can hold basically anything inside of it. And it's basically, you can think of it like a word, a number, but it's actually just you can think of it as like words and sentences. That's what it's mostly going to be used for. A character is just like a single uh, character or a number. So it has to be, it can be, it's like basically just a single part of this string. So it's like just an A, or like just the character one, because character one is actually different than integer one. And you guys will learn more about that later on, like how they're mostly different. But there is a difference between like, if I did int x equals 4 and like char x. Oh, okay, I might not, sorry, my handwriting is really bad on this mouse. So there's a difference between like this and this. If you're actually trying to use the number 4, just go with the integer way, because if you try to use char x in this case, it will be completely different, because this is a little bit more a high level concept, but they might have kind of talked about it, is that like characters have like a number associated with them. So like I think like capital A is like 32 or something like that. And so that's why if you try to like use the character 4 instead of like the number 4 for like operations, it will, because the number 4 I think has a different actual like value associated to it, like this, than the actual integer 4. So anytime you're just going to be using a number, just use an integer or a double. Never use like characters. And then we know that Boolean is just true or false statements. There's really nothing else besides true and false. Okay, so we're going to talk about the difference between declaration and initialization. So basically, when you declare a variable, you're basically just saying there's going to be an integer x, but you didn't give it a value yet. So you're basically telling basically your code that, hey, I have I have a variable named x, but you never assigned it a value. And then initialization is when you actually assign the value. So most of the time you do it in one step, where you do it like this code right over here. So that's both declaring and initializing in one step, because you're pretty much anytime you say int x, that's declaring. And then when you say equals something, that's initializing. So normally how you do it is this way, and that's basically doing it in one step. But if you wanted to, you could break it up into 2 steps like this. You first declare the variable, and then you initialize it. And then they both do the same thing. There will be small amount of situations where doing it like this way will be better, where you want to like make your variable first and then use like declare the variable like way later in your code, or sorry, initialize the variable way later in your code. But a lot of the times you're going to be doing it this way. And then variable operations. So if we set like 2 variables equal to each other, they need to be of the same type. So like, for example, I can't say like if I take these codes above, I can't say like x equals y in this case, because x is an integer and y is a double. So if we're going to set 2 variables equal to each other, they both have to be of the same type. So either like both integers, both doubles, both strings, and whatnot. So like so like in the example above, so if I say like int number equals x, essentially what it will do is it'll have number will hold the same value that x has, because they're both integers. So you see x is an integer and number is an integer. So this operation works, and all it does is basically say number is also equal to 3. Cool. Any questions on variable syntax? You guys have done this hundreds of times. You'll do it hundreds of times pretty much per code. So this stuff should be, pretty straightforward. And again, If you have any questions, feel free to stop me, talk or type in the chat or anything. So now we're going to go over if statements. So the basic structure of an if statement basically looks like this. It's the keyword if, and then anything inside the parenthesis has to be something that evaluates to true or false. You can't just say something like for example, if I say like if like x, so people do this all the time, like if x equals 2. So keep in mind what you do here is you're initializing the variable x to be 2 because you're saying x equals 2, kind of like what we were doing in the previous ones. You're basically in that if statement, you're basically doing this line of code right here, which is not what we want to do. What we're trying to do is compare x to the number 2. So how we compare stuff, and most of the time, like how we compare most things is using this double equal sign. So that basically means does x equal 3, not set x equal to 3, which is one equal sign. So anything inside the statement, inside the parentheses, has to be something that ends up being true or false. So most of the operations you will use is like double equal signs, like less than, greater than signs, because all that it'll give you a true or false statement in return. And then one common mistake that you'll see is that people will sometimes put semicolons after the if statement, like kind of like how I just drew, and it won't give you an error in that case. But what it does is it checks the condition, and even if it's false, it will still go into this bracket. So basically, even if you have the semicolon there, no matter what, it will run this code, which is, a lot of the times what you're trying to prevent with if statements. So make sure if you're doing an if statement, just if or while loops when we get there, if, else ifs, and while loops will not have a semicolon after them. Because if they do, it'll mess up your code. And sometimes it's hard to catch because it's like one tiny semicolon that's making your code all wonky. So remember, if you have a semicolon, it's always going to run this block of code, which we don't want to do. If we don't have a semicolon, it will only run the block of code once this is true. So else ifs basically follow the same formatting as ifs. We just have the word else ifs. So you can basically think it's like, if this is not true, then I'll check this condition. And if that's not true, I'll go into the else. Because basically the else means like if both of these fail, then it will just fall into under this category. And else doesn't need to have any parentheses because it's basically like, you can think of it as anything not checked in these two if statements. So like how this one compares it to x, or x equals to 3, this one's greater than 3, then that means pretty much any other number, like else is just, it'll go into the else as anytime that x is less than 3. Because equal to 3 is checked here, greater than 3 is checked here. So the only remaining things that if it doesn't go into one of these two, the only remaining thing is if x is less than 3. So that's why it will print out this, because we already did the check to see if x is equal to 3. We already did the check to see if x is greater than 3. So that means the else, anything that falls under the else must be x is less than 3 in this case. And that's why we don't need any parentheses here, because it's basically saying anything that's not this condition or this condition. So can anyone tell me what's the difference between having like an if else rather than two ifs? So what if I just change this else if to just an if? What's the difference than having an else if? Does anyone know? So let me
Both of them are always going to be executed.
did you say both of them are going to be executed?
Yeah, so if you fail the first if statement, then the second statement wouldn't execute. But in the case that you use another if statement, it's going to check the condition. It's going to check the newer condition and then decide whether it should execute or not.
Yeah, essentially. So essentially the difference is with ifs and else ifs, like let's say that in this case, we know that x is equal to 3. So we know that it's going to go into this print statement right here because x is equal to 3. So it'll print this out. And so what ifs and else if does is that if it goes into one of these, it will not even check the conditions for any other one. So it won't do any of this. And it will just jump to the first line of code after all the if and else if statements. So it will go to line 18 in this case. But if this was just an if, what it will do is we will say that, x is equal to 3. And then, okay, we will print this out. But since this is another if, that's not like, because an else if is associated with this if. But since it's another if, it's not associated with that if. So it will check this condition again. So let's say that x equaled 4 instead. Actually, okay, I guess that would be, let's say that this was if x is greater than or equal to 3. So this block of code should also run if x is 3 as well. So what would happen with an if and an else if is that so it'll with an else if, it'll run this one first because this is the first condition that it'll find true because x is still equal to 3. So it'll print this out. But since it went into this if statement, it won't even check the conditions for all the else ifs. So even though this condition, right, let me erase all this. So even if, so remember this one's in this case greater than or equal to 3. So even though this condition is still technically true, because it went into this if statement, it didn't even check that condition. But if this was an if instead of an else if, so like pretend this was just an if statement, what it will do is it will see that this is true, run this one, but then it will still check this condition and it will see that this one's true as well. And then it will print this one out as well. So it's a small difference, but sometimes it can be a big, it can have a big outcome. Does that kind of make sense? So else ifs, if and else ifs will basically saying that if it goes into one of them, it just doesn't even check the rest of it and just goes to the next line after it. Having multiple ifs means that it will check the condition for each one. And then keep in mind this right here is that you can have an if statement without an else, but you cannot have an else without an if statement. So I could just like, if I wanted to, I could just have like if I could just get rid of all of this and then just have like this block of code right here. And then it will still work perfectly fine. All it will do is it will compare this condition, and if that condition is false, then it will just jump to the next line. It doesn't have to, there doesn't have to be an else or anything, but a lot of times, it's kind of nice to have an else. Any questions on if else statement, else statements? Anybody want me to re-clarify anything? So yeah, keep in mind, just no semicolons. I can't think of a single time that you will ever actually need to put a semicolon at the end of an if statement, because then it kind of makes the if statement useless. So just always forget to not put a semicolon there.
Excuse
And
me.
yeah,
So basically with two, so if you have two if statements, it has a there's an opportunity that it can go through both of them. But if it's an
exactly.
else, it's only gonna run through one of those conditions.
Yep, exactly.
Okay.
So if there's two if statements, it will check the conditions to both of them. Even if it goes into the first one, it'll still check the condition for the second one. And if that one's true, it will go into the second one as well. But if it's an if and an else if it goes into the first if statement, it will not go into the else if. It'll just like skip over it. So sometimes you might find more value using two if statements rather than an if and an else if. And I can show you an example of that at the end. So again, we're just going to talk about like the true false operators. So basically, we're basically going to talk about the condition. So keep in mind that anything inside the parentheses needs to be a true or false condition. So most of the time you'll be using like the Boolean operators, which is like, double equals, which is, we're just checking to see if two things are equal to each other. This is not equal, so we're checking to see if one thing is not equal to another thing. And then we know it's less than or equal to, greater than equal to. So a lot of times we'll be using these type of operators in some way. So these operators work for all primitive data types. So primitive data types are basically any data type that's just built in. So like integers, doubles, booleans, chars. The only one it does not work for is strings. You can't say like one string equals another string. That's why you have to use like the dot equals or the dot compare to, because it does string. And you'll learn, if you have any more programming classes after this one, you'll learn why string is not a primitive data type and why double equal sign does not work. But just keep in mind, it works for all the other, like all the simple ones, such as like ints, doubles, booleans, and characters. But with strings, we have to do the compare to. But if you even notice in the compare to, we still do a double equal sign, because what compare to does is just it it finds the distance between two numbers. So if I say like A dot compared to B, it'll give me -1 because A is like one place behind B. So like, so if I say like A dot like compared to, I'm not gonna write that all out, compared to B, what this will do is it will give me the it'll give me -1 in return. So if I say like this is less than 0, that means that this value right here, whatever string it is right here, is like comes before in the alphabet before this one. And then greater than is, the opposite. So that's why we do double equals. We want to see if they're exactly the same. So it will only return 0 if like both strings are exactly the same. So that's why you do like dot compare to equals 0, because you're just checking to see if the strings are exactly the same. If you do greater than 0, that means the first string comes after whatever's in the parentheses. If you do less than 0, that means whatever the string in the parentheses or the string before the parentheses comes before it. Cool. So now we're going to talk about switch statements. They're a little bit, so a good way that I like to think about switch statements is that it's basically a more efficient way to doing a bunch of if and else if statements. Because if you think about it, that's essentially what a switch statement does. It's a bunch of if and else ifs. So the one key difference is that we have this keyword break, and I'll tell you what basically that is used for. So basically it will always follow this same similar syntax, is that we'll have a switch, like the keyword switch, then we have like a variable. So what happens is that it takes this variable and compares it to all these cases, basically like a bunch of if and else ifs. And so the reason why we need to have these break statements is because there's something called fall through, that means that if I don't have this break statement here, what it will do is it will keep like so let's say input is A in this case. So input, sorry, my handwriting is really bad. So like input equals A, like the string A, because that's what it's comparing to. If that's true and I don't have this break here, it'll set number to 0, but then what it'll keep doing is it'll just keep going down and running every line of code until it hits a break statement. So then it'll hit this one here as well. And then it sees a break, so then it will stop. So instead of, like, if we wanted number to be 0, if we saw an A, well, if we didn't have a break statement here, it would go into the B case as well, and that's what's called fall through. And so that's why you want to have the break, because that tells it, okay, stop running the lines of code and basically go down to here. So if we don't have that break there, like if we never had a break like this, if all of them didn't have breaks, what it'll do is like set number to 0, then set number to 1, then set number to 3, and then it'll hit the default and set number to -1. And that's not what we want to do, because that's kind of, redundant. That's basically saying, we want the goal of the switch statement is that basically compare it against all these cases, and depending on the case, do a specific thing. But if you don't have the breaks, it will always just do this one, which is not what we want to do. So default, you can think of it as like the else statement to all of these. So this is like an if, else if, and then default's like the else. So if none of these are true, it'll go into the default. So we don't need to have a default, similar to the reason why, like with ifs, we don't need an else. It's just, we don't need the default, but sometimes it's still nice to have it there. So if it's like if it's not any of these ones, we can do a specific thing, but you don't need the default there. So yep, the default case is ran anytime that none of these cases are true. But similar to like if statement, it will run this one, like if the case is A, so if input is A, it'll set number to 0, and then we need to make sure to have these breaks there. But let's say we want a situation where if the number is A or B, we want it to do the same thing. So let's say like if input is A or B, we want to set the number to 1. What we can do is we can actually just do something like we can say like case A, kind of like this, like what we have, and then don't put anything in it, just follow it up directly with case B. So what this will do is if case A is true, and let's say we had like code for case B, and we had a break. Keep in mind, have the break. So what will happen is if case A is true, what it will do is it will, since there's no code for A, it will do the code whatever one's right underneath it. So it will run the code for case B. So that means like, this basically means if case A or case B run this code. Does that make sense? In what cases would it be smart to switch instead of an if-else statement? They essentially do the same thing. A lot of times it's easier and less code to use a switch statement. It's, yeah, a menu is good to use anytime, like you kind of want to prevent having like a bunch of else ifs, like if, else if, else if, else if, else if, else. If you're gonna do that, it looks kind of sloppy and it like takes up a lot of lines of code because you have like all the brackets and whatnot. So if you have a bunch of if and else ifs, then it's better to use a switch. But if you have just like an if, one else if, and then an else, it's probably better just to go to the if and else if else route. So yeah, the only time really switch statement is a bit better is if you're gonna have a bunch of if and else ifs. Then switch statement just is more compact. Because like instead of, because this is what this is like 14 lines of code compared to if and else ifs, which might be like 30 because you have so many like curly brackets and everything like that. Yeah, no problem. All right, so we're gonna step away from switch statements, and then I can always go back and re-talk about something. So if you guys want me to go back to any previous slides, just let me know. So now we're gonna start going into the loop territory. So the first one we're gonna talk about is a for loop, because as you guys go on, if you do any more programming classes after this one, you'll see that for loop will end up being the most common one you use. It might not be the most common one you use right now because it can get kind of funky sometimes. So, but for loops will be one of the most useful tools later on, especially if you guys notice, because you guys probably, you guys have learned arrays and you know to iterate through an array, you typically just use a for loop because it does everything kind of nice for you. So the structure of a for loop pretty much always follows the same thing. We do our initialization. So this is where you typically do like your int I equals 0. And keep in mind, it doesn't have to be I. I is just kind of like the standard. You can name the variable whatever you want, but I is typically the standard, and it typically represents iterator. That's kind of like shorthand for iterator, but you can name it whatever you want. And then the condition. So this condition right here is basically, you can think of it like a condition in an if statement, because this is kind of what you would put in an if statement, right? Like if I is less than 5. So the condition would look exactly like how it would look in like an if statement. So basically what it's saying, like in this code down here, is that we want to keep running the code while I is less than 5. So the moment it's 5 or greater, this code should stop. And then right here is our iteration. So iteration is just what we're doing with I to get basically, this is our, how do I word this? So what are we doing with I to get closer to this condition, I guess? That's probably one of the better ways to put it. So I++, you can think of it like I, just keep in mind, if you haven't really worked much with I++ or not really sure what it does, it pretty much just means I equals I plus 1. So just think of it like that way. And you don't have to have I++ there. You could have something like I equals like I times 2. And that will make it like, get to this condition faster, because instead of increasing by 1 each time, it's doubling each time. So this condition is just basically any way you want to increase I. But most of the time, you're going to be doing like I++. You want to increment it one at a time. So yeah, if we run this code, I starts at 0, so it'll print hello world 0. Then it goes up to 1, checks the condition again. 1 is less than 5, so it goes back into the for loop, and then prints out hello world with the new I, which is 1. Goes back up, iterates I to 2, and then so 2 is less than 5, and then we basically keep doing that until after we print out hello world 4, we go back up to the for loop, iterate I to 5. Well, 5 is no longer strict, because remember, this is strictly less than 5. So it's not less than or equal to. So when I is 5, 5 is not less than 5. So this condition is false. So that means then it will stop the iteration. So what it would print out in this case is 0, 1, 2, 3, 4, but it doesn't print out hello world 5 because 5 is not less than 5. Make sense? And then keep in mind when we get to the next section, I think the next part is while loops, is that this condition right here is essentially what you would put in a, just like, it would be the only condition in the while loop. So like I could say like while I is less than 5, like this is just the stopping condition, similar to, yeah, so I literally did it right here as well. So I used the same condition, I is less than 5. So it has the same stopping condition. So in this case, while loop, it doesn't have any like iterate or anything. It's just looking for a condition over and over again. It's not having any, in this case, we're doing it slightly different, but in the most part, like the while loop itself, like the condition, it just is looking for a specific condition. It's not incrementing any variables. It's only looking to check while I is less than 5. And then in about 2 slides, we'll go over when it's better to use each one. So if you have a question on that, just wait till those slides. So while loop is simply just the condition. There's no variable, or there is a variable, like that's typically what you're checking the condition for, but there's no variable that you're like incrementing or anything. You don't have to, it's only like the middle syntax of the for loop, which is just our stopping condition. And that's all it is. So it's basically keep running this code until this is false. Similar to the one before, but we're not like doing int I equals 0, int I is less than 5, I plus plus. It's simply just the stopping condition. So this is actually what we did in this case is this code right here is actually, it will do the exact same thing as the code from the previous slide. So if we go back, oops, let's do while loops. So if we go back, so we are actually using an iterator in this case. What we did is we set I equal to 0 before the while loop. And then we say while I is less than 5, system dot out dot println hello world at I, and then iterate I. So this is basically the while loop version of how to do the code previously. But you don't need to do it this way. So like, let's say you wanted to have, make a program that keeps taking in user input until they type the word hello. So in that case, like you don't really need an I because you're not really incrementing anything. You're just looking for a certain condition, while they type hello. So basically the condition in there is like, while, the word they type in is not hello, keep taking in user input. So the moment they do type hello, this becomes false, and then it will stop the while loop. So while loop is just checking for a condition, while for loop is incrementing something and checking the condition. And we'll go over which one, like when to use one and when one's going to be better over a different one. So do while loops are very similar to while loops, but the difference is that a while loop checks the condition first and then does the code, while a do while loop will do the code first and then check the condition. And in a good amount of situations, they will do the same thing, but I'll show you a different situation when they do something different. So the syntax is basically we do our do, brackets, then our code, basically inside the while loop, and then our while condition right here. And the one thing about a do while is that you do need a semicolon here. I don't know exactly why, but in the form of the syntax for a do while loop, this part has a semicolon. So it's different than, if you notice from the previous slides, the while loops and the for loops do not have semicolons. Only the do while it does. I can't tell you exactly why, that's just the syntax. And if you don't know what the word syntax means, it's basically just like the structure, like how it's laid out. Like syntax means you have to follow the syntax for your code to work, essentially. So yep, right here, it's similar. It does the exact same thing as a while loop, but instead of checking the condition first, it checks the condition last. So in this case, we have int I equals 0. Basically the same code as we had before, but in this case, we're doing a do while loop instead of a while loop or a for loop. So we print out hello world at I, increment I, and then it checks the condition. So the difference would be is, what if I set I equal to 5 right away? So it like fails this condition. Well, in a do while loop, it will still actually print this. It'll still run the code first because it didn't check the condition yet. It never checked if I is less than 5. So even though I is 5, it'll still run this code first and then check the condition and be like, oh, I is 5, so now it stops. Compared to the while loop, where if I set I to 5 right away, So if I set I to 5, like right here, they'll check the condition first while I is less than 5. Well, I is 5, so it doesn't even run this code at all. So that's the difference, is that a do while loop will always run at least one time. And that's why typically do while loops are typically a little bit better with menus. If you need to keep like printing out a menu, because you normally want to print out a menu at least one time. They could print out a menu and then hit quit right away, but it still needed to print out the menu once. So typically a do while loop would be better for menus. And I think I actually discussed that when we go to when a loop is better than another. So yeah, just keep in mind that a do while loop is essentially just a while loop, but instead of checking the condition first, it checks the condition last. Simple. So now we're going to talk about when to pick a certain loop over another. And keep in mind, you can use basically any loop. Like all loops can be used interchangeably. Like I can make, if you notice, all these do while loops and for loops and while loops all do the exact same thing. So they all print out hello world 0, 1, 2, 3, and 4. So you can make like I can make a while loop that does the same thing as a for loop, and I can make a do while loop that does the same thing as a for loop. But sometimes, if you notice, like here, it's a lot less code. Like this is basically just 3 lines of code compared to the other 2, which is like 5. Okay, 4 lines of code. Oh, I guess the for loop was 2 lines of code. So yeah, this one's double the line of code. So they do the exact same thing, but sometimes it's more efficient and looks better to use one over the other. But they can all be used interchangeably. So for loops are normally best when you either know when you want to know how many times the loop runs, or when you know the exact stopping point. Like I want this loop to stop after 5 iterations, like 4 iterations, 3. When you know exactly how many times you want the loop to run, typically a for loop is better. Well, a while loop is typically better when you don't know or don't really care how many times it runs. You're just wanting to run until a stopping condition is hit. Like for example, like the example I brought up earlier, is like if I want to keep taking in user input until the user types in hello, and then I want to do something when I type in hello. Well, in that case, I don't really care how many times they type in numbers before I get to hello. I only care about when they type hello. So in that case, a while loop would be better because I didn't care how many times it went through the loop. While a for loop, it does care. It will count how many times it went through. So like an example for a for loop is like when you want to print something exactly 7 times, a for loop is typically better in that situation because then you have your I variable and you do I plus plus 7 times. And then, while I is less than 7, do this. So that's when for loop's better. So an example is like when you want to print something while the user input is yes and stop once it's no. Yeah, like in that case, we're not really caring how many times they type yes. We only care about when they type no. So in that case, we're not really counting. We're just looking for a certain condition. And a do while loop is basically has the same, same premise as a while loop, but typically when it's better is in stuff like main menus. When you want to do something at least one time, then do while loops are typically a little bit better. Okay, so we're going to step away from the while loops or from the loops. Anyone have any questions on any of this? We probably are going to end up going, because normally this was supposed to end at 1, but it'll probably go over that. So it's not a big deal. You guys can leave at 1. This will also be, it'll also be recorded. So I put it like a tentative time of 1, but we'll probably go over that. Cool. If no one has any questions, then we're going to move on. So we're going to talk about infinite loops. So infinite loops are bad, obviously, right? Because it means that it's never going to leave the while loop, which means your program is never going to run, or never finish running, which is bad. And I bet all of you have run into an infinite loop at least once, and you'll do it many times. And I still do it all the time. So we know that an infinite loop happens is when the stopping condition is never met. So taking this code below, it's basically the same code we've been using for the while loop. So we say int I equals 0, and we say while I is less than 5, and we print out hello world, but we took out the I plus plus part. That means we never incremented I. So I is always 0, but the condition is always checking if it's going to be greater than or equal to 5. Well, that condition will never be false. Since I is always 0, 0 is always less than 5. So this code will run infinitely. It will never stop. And most of the time that is not good. So, because your program will never finish, and then I don't want to say it can crash your computer, but it will take up a lot of memory in your computer. Not fun. So if you ever getting an infinite loop, the reason is that this condition is never being met. So you need to figure out why it's not being met. Cool. So then we're going to talk about taking user input. You guys have probably done this plenty of times, like in every assignment, but we're going to still talk about it anyways. So we're only going to talk about the scanner. There is different ways of taking user input, but the scanner is the easiest and will be the most common one that you use. So we're only going to talk about the scanner. So the first thing you want to do is just import that scanner library. You have to do that every time, because if you forget to do it, you can't even use the scanner. So we know that that's just like the import java.util.scanner part. Just put it at the top of your code anytime you need to use the scanner. So before I use the scanner, I have to create it, which you guys have seen, you've probably done many times, where you just do like scanner and then you name your scanner equals new scanner system.in. You'll do that every time. I have to create a scanner to take in user input. If you don't create the scanner, then you really have no other way to take in user input. So then the scanner has a couple of functions that you can use with it. So like the most common ones that you'll use is like next or next line, next int, and next double. So a lot of confusion is, so we know that next and next line are used for strings, but a lot of confusion lies on what's the difference. So let's say I have like the user types in a bunch of numbers with like spaces in between. So next line will take in this whole entire thing, while next will just take in the first, like pretty much everything up until the first space. So just the 0. So if I want just the first number they type in, or the first thing they type in before a space, I would use next. But if I just want the whole entire thing like this, I would use next line. So like if they typed in like hello world, next will give me all of hello, because it keeps going until it hits a space. So there's a space right here. So next would give me hello. And then if I did scan.next again, it would give me the world. While if I did scan.next line, it would give me both hello world. So we know that, and then we know like scan.next int, it basically waits for a number. And you'll notice that if you do like scan.next int, like I don't know why I'm writing that out, but if you do scan.next int and they type in like a word, like if they typed in hello and it's looking and you did scan.next int, it'll crash because hello is not an integer. So it's looking for an integer, but hello is not an integer. So make sure you're using the right like scan.next int or scan.next line, depending on what they're going to be typing. So scan.next double, same thing. There's basically a scan for pretty much every data type, like integers. I think there's even one for Boolean. I don't know when you would use that, but it's there in case. And then close the scanner. It won't get mad at you. Well, it'll get mad at you if you don't close the scanner. It'll give you a warning. And in your guys' class, it's not going to matter as much if you don't close it, but it's always proper to close it, because then it'll save you some trouble in later classes where it could become an issue if you don't close it. So just all you do to close it is just once you're done taking in user input, you just do scan dot close. And then all that does is that means that like the scanner is not going to be in use anymore. Keep in mind, it won't give you an error if you don't do that, but it's proper to do it. So when it takes in user input, you'll notice that like what it'll do is it'll interrupt the code. So if I have like a bunch of stuff and then I have like taking in user input, and then I have a bunch of stuff after it, basically it'll run your code. And then when it gets to this point, it'll stop. It'll stop until the user input, like you guys seen where it pulls up like the terminal and everything. And then it waits for user input. They type something, hits enter, and then it will continue to run the code. So it completely stops the execution of the code. Yeah, and then this basically right here is what I was saying before. If the type that the user types in does not match what like the next you're using. Like if they type in like hello, but you used scan.nextInt, it'll crash. So make sure you either tell them which type to use, or make sure you're using the right type. So any questions on the scanner? Because here's an example right here. So again, I had to import the library right here and then make the scanner object right here. So again, like I said, it's just your scanner. You just say scanner, and it has to be capital. And then you can name it whatever you want. It's Scanny in this case. And then you say new scanner and then system.in. So this is how you'll do it basically every time. The only thing that will change is that you can name it something different, but everything else will be the same every time. So like scanner and then the new scanner system.in. They'll basically be the same every time. So then you can see like this block of code is expecting a number because we're using scan.nextInt. So it will print this prompt, wait for user input. And if they type in, let's say the number 4, then it'll save num as number 4, and then it'll print out number 4 in this block of code right here. And basically the same thing goes with the rest of the code. So like next double, it's waiting for a double. So like, like 3.4, it'll take that in, and then it'll print it out right here. And then same thing with the string. So in this case, we're using next. So it's basically every character that we see up into a space. So like hello, if we typed hello space world, str, since we're using .next, will just hold hello and not world because it takes everything up to the first space. And then we close the scanner. Cool. Any questions on scanner? If not, we're going to go to arrays, which, you guys probably are having a lot of fun with now. So arrays, again, they kind of follow a similar syntax as just making like a normal variable where you'll go your type, and then you add these like brackets here. That's how it knows that it's going to be an array. Then you give it a name, and then there's two things that you can do. You can either like give it all the things that are going to be in the array, like doing it this way, which is basically what we're doing like down here, is that we're creating an array with already things inside of it. So you can do it this way, or probably the way you guys have been doing it more often is the other way, where you say like, your type brackets name equals new type, and then you give it like how many indexes they're going to be. So what that does is it just creates an empty array of, in this case, size 5. So there's two ways you can do it. You can do it like one of these ways, where you actually put everything inside of it already, or you can just create an empty one of a certain size. So we're going to talk about what this does. I don't know if any of you have run into this situation where you set one array equal to another array, and it's giving you some weird things kept happening. So we'll talk about that briefly, but you don't need to really understand it that much. I'll just tell you kind of the rough idea why it's not a good thing to do that. So before we get to that, any questions on just the basic setup of making an array? So what this does is it will just make an empty array. Well, it's technically not empty, because what it'll do is it'll throw in the default value for whatever type you have. So for integer, the default value is 0. So it'll make an array of 5 zeros. So if I set like for string, if I did the same thing with string, well, the default string is just like an empty string, which doesn't even have a space in it. It's just like this is the empty string. There's no space or anything in it. It's just like the open quotes and then the close quotes. Same thing with character. It's just like nothing in it. So if you do it this way, it'll make an array of size 5 and then just throw all the default values in there. And then, if we want to, I think, do we end up talking about that? Hold on, let me go a couple slides. Okay, yeah, we do. Okay. So before we go through like indexing an array, I want to talk about what this is doing. So I'm setting two arrays equal to each other. So the common misconception is that if I have two arrays, like let's say I have one integer array called like, it has like 1, 2, 3, 4 in it. And let's say that one is R1. Say R1 equals that. And then we make another array and we say R2 equals, and then let's say you know, like 5, 6, 7, 8. If I say R1 or R2 equals R1, what a lot of people think it does, and it will look like it does this, is that people think that it fills this array with the same elements of R1. But actually what it does is that instead of R2 referencing a new array, it will make it reference this array as well. I know that sounds weird, but I'll show you an example in the next slide. So that's called aliases. And aliases, as you guys heard before, is just like it's like the English word alias, which is basically two different names for the same thing. So what happens when you set two arrays equal to each other is that they're talking about the exact same array. So if I change like one array, it changes both the arrays. So if I say like array 1 equals array 2, and then I change like a certain value in array 1, like array 1 at index 2 equals something, then it will change this, it will change that index for array 2 as well, which in a lot of cases you don't, you know, you don't want to be doing that. You want to be changing just one and not both of them. So that's why it's not really good to set two arrays equal to each other. If you want one array to hold the same elements as a different array, you would create a new separate array and then like for loop through this one and put them all into this one. So you would put it in individually rather than just setting two arrays equal to each other. Because if you do that, then they will be, when you change one, it'll change both of them, which is typically not what you want to do. And then this block of code right here is basically just showing that because it's using the previous code before. That's just, it was assuming that we're basically saying that array int 2 equals array int. So again, they'll both be this. And then if we go back to this code right here, then if we see that right here, we're changing index 3 of array into 1. But if you ran this code down here, where we never did anything with array int 2, we never changed it, but it will change it in the output. So it changed index 3 of array int 2 to 1 as well, because they're both talking about the same array instead of two equivalent arrays. So if you set two arrays equal to each other, when you change one, it changes both. That's basically the idea I want to get across. So most of the time you don't want to do that. So if you want one array to have the same values as a different array, you would just create a new array and then basically for loop through the first array and put the numbers manually into the other array. It's kind of tedious, but you got to do what you got to do. So we're going to talk about traversing through the array, and then we don't have too much left. Yeah. So we're going to make it on time. I know we're going to go a little bit over, but then I'll still have time for the Q&A. I'll still be around for that. So we only have like 2 more slides. So traversing through an array, we know that typically, so this is where like the for loop comes in handy, is because we kind of know exactly how many times we want to go, we want to loop through it. Because like if this, like in this case, the array is of size 5. So if I want to print everything in the array, you know, I care about how many times I'm looping through it. Like I want to loop 5 times. So that's why like a for loop is typically better to iterate through an array rather than like a while loop. So the for loop here is, and keep in mind, arrays start at index 0. So if I have like the array, you know, in this array, like 6, actually, I'll just use the 1. So, so even though this has 5 elements in it, they're indexed starting at 0. So it goes index 0, 1, 2, 3, 4. So if I wanted to get like the 6, instead of doing like array at like 1, I have to do array at 0. Because it starts at index 0 and goes up to index 4. So that's why if you ever noticed, if I wanted to get like the last index of an array, I would have to do like my array.length -1. That will be the index of the last number. Because like in this case, array.length returns how many elements are in the array. So 5. But if I try to index at 5 in this case, there is no 5th index. Because remember, it's 0, 1, 2, 3, 4. This will give me an error. So if I say, so remember, r.length is equal to 5. So if I try to index at 5, there is no index 5. So you'll see that error that's like index out of bounds. So that's why if I want to get the last index, I would do r.length minus 1, and that will give me index 4, which is the index of the last thing in the array. So yeah, so a for loop is the best way to go through it because we care about how many times you want to go through it. So you would start at 0. If you want to go through it from like left to right, you would start at 0. Basically say while I is less than, if you know exactly how many things are in the array, you can just say like less than that number, or you can say like while I is less than int array dot length. That works as well. And then if you want to go one by one, just do I++. And then how we index it, like how we talk about the actual number at that index, we have to do it this way. So we say our array name. So in this case, it's called int array. And then we do those brackets. And then in the brackets is like what index we want to get. So in this case, we're doing I. So I starts at 0 and then goes to 1, 2, 3, and 4. So when I is 0, it'll print out the number 6 because that's at index 0. When I is at 1, we'll print out index 1, which is 7. And then, you know, at index 2 is the number 2, and so on. So that's basically how you just traverse through an array. So for loop, starting at 0, going into like I is less than the length. Because sometimes what I see people do is that they say like I is less than int array dot length minus 1. Well, because what you're saying in that case is, so int array dot length is 5. So if I say I is less than int array dot length, that is basically saying while I is less than 5, which is fine. But if I say dot length minus 1, that means while I is less than 4. So what would happen is when it gets to, because the last index is at 4. So you can think of, if I say r dot length minus 1 here, it's basically saying while I is less than 4, it wouldn't print out this one at all because it would stop when I is equal to 4, which is at this last index. So that's why if you're going to do it the r dot length minus way, don't do r dot length minus 1 unless like unless you do like I is less than or equal to r dot length minus 1, you could do that. But if you're using strictly less than, then you have to do just r dot length. Make sense? Anyone have any questions about that before we move on to probably what you guys are learning now, which is class and functions? Very fun. Probably the bread and butter when it comes to programming, and you'll see why it's super important on your later classes if you have later classes. Cool. If no one has a question about the previous stuff, we'll talk about this. So class structure will basically follow the same thing. So it'll go our visibility, which is, you know, the keywords like public, private, or protected, the word class, and then the name of our class. So like we can see that up here on line 1. So public class, hello world. So this is similar to like how we basically make our general code. Like if you look at pretty much all the code I've had that line of code. You know, public class, hello world. Pretty much anytime we make a new file, we need to add this part. And remember that this name right here, for the most part, if it's like the first class that you have, like this class right here, it needs to match the file name. So this, you can assume that this file name is named hello world. If you don't, then your computer gets confused. So typically a class will have attributes. So attributes are essentially, because anytime you, so you guys have heard of the word object, and then especially like an object of a class. So if I make an object of this hello world class, you can think of it as I'm making like an instance of it, like a single like block of it. And it has these two attributes inside the block. So like int attribute 1 and int attribute 2. Sorry, it's hard to write. Oh wait, this is supposed to be 1. And then attribute 2. So this is what's called like data encapsulation. So what you do is like you basically have two variables in under one variable. So you have like, because you'll have this one variable that references this object, And then inside this object will have 2 different variables. So the reason doing this stuff is nice because instead of having like 500 variables, you can like, let's say you have like a student, and a student has like a name, an ID, and then maybe like a list of classes. So let's say you want to talk about like 10 different students. Well, each student will have like 3 variables corresponding to like their name, their ID, and their list of classes. So instead of making, like 30 variables, it'd be nice to make just 3 students that have each 3 variables inside of it. Yeah, so if anybody joined late, the recording of this will be posted on the YouTube channel right here. So if you have any questions, if you want the recording, that will be posted there after a few days, because after all the editing. So yeah, so when I'll go after that, after I finish this slide, I will finish talking about what creating an object means. But let me finish the class structure. So class structure is basically just this part right here, where you say public class, hello world, and then the brackets. And then the function structure is basically the stuff that goes inside of it like this. So this is a constructor, which you guys have probably seen before. And what it does is it just holds the visibility. So most of the time for a constructor, it'll be public. And I'll show you why when we go down to the visibility. And then for a constructor, the name of it needs to match the name of the class. So in this case, it's called hello world, and then you just add parentheses. So what this constructor does is like when I create my box of this class, if I use this constructor, what it will do is it will give my attributes inside of it these values. So like 0 and 1. So when I first create it, attribute 1 will be 0, and then attribute 2 will be the word hello. So that's what the constructor does. It assists you in building the square. And so these functions right here can be used after I build the square. So, and those formats typically just follow like this. It goes, again, the visibility. So if you look at right here, it goes the visibility. So either one of these right here, public, private, or protected. The return type. So I guess whatever we want to, so like if this function needs to save any variables, like we want to use like a result of this function somewhere else, we need to return that variable right here. So whatever variable we want to return, the return type needs to match that variable's type. So if you look at this function right here, we're returning attribute 1, and we see that attribute 1 is an integer. So the return type of this function needs to be an integer. And then the name right here, again, the names don't really matter in the case of functions. They're just, in this case, it matters for the constructor case, but in this case, it doesn't matter. But again, it's really nice to name them based on what they do, because if I just name this function just like X, if I call like this function .x, looking back, if I come back to this code like 3 weeks later, I might forget what this function does. But if I named it, get attribute 1, I know that it will just return me attribute 1. So, and then like what return does, essentially what you can think is it's like throwing it back out, like in the sense that, let's say we had a bunch of calculations in this function and we wanted to return the result. So what it does, it will do all the calculations and then it will give us the calculations back rather than just doing the calculations and not doing anything. If you don't return anything, this function doesn't give us anything back. And we'll go over a little bit of examples of that later. So again, the return type just must match the variable that's being returned or the object being returned. So in this case, I kind of demonstrated, if you don't put a visibility there, it defaults to protected. So if like in this case, you just say int add 1. So there's no public, there's no private, there's no protected. So if it doesn't see anything here, it will default to this one. And then here's our main method right here. What is the difference between get method and set method? Yeah, I'll go over that in just a second. Let me finish this part real quick. So, and then remember what I was saying earlier, it's like public static void main, it has all these weird keywords in it, right? But now based on this slide, we can kind of figure out what they mean. So public is the visibility. So for main, it's always going to be public. And I'll tell you why. Like when we go over the visibility, you'll see why. Static is one of those words that you saw probably very briefly and are very confused upon. It basically just means that anything done in this function, yeah, static is always a weird thing to explain. But static is essentially that if I run this code, it's, in this case it's main, but if I have a different static function, anytime I run that static function, it'll run it for every, like, so let's say I have multiple boxes pertaining to this class. And I have a static method. What a static method does is it will run it in all the classes rather than just like all the boxes instead of just the one box. And static is very confusing, and I don't want to spend too much time on that. It's not a very important thing. So I would just recommend doing some research, and it's not very, I don't want to say it's not very useful, but it's not used very commonly. So I'm not going to go delve too much deep into that. If you have any questions, just ask me afterwards on static and I'll try to go over it, but we're not going to talk much about static. So someone asked, are the methods the same as functions in our case? So a lot of the time they're used interchangeably, methods and functions. So sometimes I'll say method and I mean functions. I think that in Java, they're essentially the same because they're tied to a class. But you'll see the difference when you come to C++, because you can have like stuff like this outside of a class. And but in Java, you can think most of the time as function and method like the same thing. Cool. So, and then this is an example of us creating one of those boxes, because what we're doing is we're saying the object, or like the class that we're getting it from. So hello world, so this class. And then we just named it. Again, you can name it whatever you want. And we say the keyword new and then hello world. And then if you notice right here, the hello world with the parentheses, that matches this right here. So what that does is it creates a box. Like this is essentially creating a box right here, a single box, and then having the variables inside it 0 and then like hello. There's another question. Why are you guys only able to send private messages? Because if you have a question, you can just put it in the public chat. So someone asked, why do we need add one here? So technically we don't need it. So the stuff about these things, they're not needed. You can make different ones of these as you want. All this is like a bunch of the stuff is, you probably heard of the words like helper functions. They're used to make things easier for you. So instead of like, so someone asked, what's the point of this add one function? So the point of it, essentially all we're doing is we're taking in a number, we're adding one to it, and then we're returning it. So in this case, it might not be very, we don't need it, but it can make our life easier for particular things. So all this stuff is basically customizable. You could do whatever you want with these functions, but most of the time you use them to make things easier for you. Instead of having like every single block of code in main, you can make these kind of like functions that will like break up that code. So your code is more organized. Because if you have everything in main, it could look really sloppy, and then it will be a lot harder to find where it does particular things. So these functions are basically used to break up your code. And you can just, and you don't always have to have these stuff. Even this one you don't need to have, because if you don't make this, if you don't make the constructor, I think you guys might have heard this briefly, but it already has a built-in constructor, which will set everything to the default value. So if I just got rid of this completely, and then I did this down here, this would still work. But what it will do is it will call in the built-in default constructor, which will set attribute. Because as we talked about before, integer's default value is 0. So it'll set attribute 1 equal to 0. And then we talked about how the string's default value is just like the empty string. It would set attribute 2 to like the empty string. Is there a convention of having the functions above or below the main method? Like your case here, the method? No, not in Java. In Java, it doesn't matter. And a lot of the time, if you guys noticed in your homework, you won't have like a lot of functions in the same file as you have your main. Typically, main will be in a file of its own, and it will use a bunch of other files that will have like a bunch of stuff like this in it. this is a very uncommon practice where you have them both in the same thing, where you have main and then main has all these functions with it. It's not very common in Java, but what was the question again? Yeah, and then in terms of like, I could have moved main up here. It doesn't matter. So what happens is like when I call the function, like right here, what it does is it like looks for it. So if I called like, let's say, add one, even though like if I had the main function up here, what it'll do is if I called the add one, it will search for the add one function. So it'll find it, oh, it's right here. So then it will run it. So it doesn't have to be below it. It could be pretty much anywhere in here because it will just automatically search for it. And then there was another question. What happens if you create the add one method without a parameter right here? So if this didn't have anything in it, so if it was just like int add one, so there's something called scoping, which you guys might have heard very briefly, but is not talked about. What scoping means is these brackets have actually uses. So what these brackets dictate, and don't get too caught up in this now, this is something that you learn like way later on. It's these brackets essentially mean that anything that I create in here it's called going out of scope, which means that like, see how I create result here? If I don't return it, when it hits this end bracket, I can no longer use result. So basically, if I create a variable between two sets of brackets, I can only use it between those two sets of brackets. So like, for example, I can't just use result down here because result is not in these sets of brackets. So to answer your question, if I just had this like, I didn't have this parameter in here and I just had if I just had like add one with like parentheses, well, it would give me an error because it doesn't know what number is. Because the only thing that it knows is, because if you notice, there's brackets right here too. So these brackets for the class. So what happens is like, since these sets of brackets are in these outer sets of brackets, the only thing that it can see are these variables right here. So if I need another variable, like for example, this number, like if I want to know what number to add one to, I have to pass it in as a parameter because the only thing it knows are these two. So if I didn't have int number here, when I try to do number plus one, that will give me an error because it doesn't know what number is. What happens if you create the add one method? Oh, that's the same one. If you declare the number earlier in the top, can you create it without a parameter? Yeah, so if I added it as an attribute to the class, so if I said int add one here, or sorry, not add one, int number. So if I made another attribute called number, then I wouldn't need this one because number is being able to seen from the parameters up here. Because like I said, like all these functions, the only things they can see, the only variables they can see is either whatever is passed in and whatever variables are created up here. So if number is not created up here or not in here, it cannot be used here. So yeah, so if you create number up here, you can use it down here. But if you don't create up here and you don't pass it in as a parameter, then you can't use it. And the same thing, so I pass in number as a parameter, so I can use it here, but after like anywhere not between these brackets, I cannot use number. I can't like use number down here because the only thing main knows so far is this parameter, which I've never seen any, like, I don't know what like, honestly, I don't know when you would ever use the parameter args for main. I think it'd be for some niche situations that you guys don't have to worry about. So the only thing the main function can see is this parameter and then these attributes. It can't see anything created in any of these other ones because it hits these end brackets and then it just erases it. So like when it hits this end bracket here, it erases it. That's the point of the return stuff. Because if I want to use that result somewhere else, that's why we need to return it. Because you can think of it as like throwing up that result. And then if I say like for example, if I say like int x equals like add one, let's say I give it the number like 4. So what it does is it saves number as 4, saves result as 4 plus 1, and then what it does is it throws up then the result, which is 5, and then x is what catches it. So x would equal 5. So there is a return type called void. So void means I don't return anything. I don't throw up anything. I don't need anything back from the function. Like let's say like you would notice like your toString methods are normally return will sometimes return void, and all it does is like print things, because like after I print things, I don't need to return anything. I just print them. So if you don't need anything from the function, like in this case, I needed results, so that's why I have a return type of int. But like if you notice, like main itself is void, because you never say like return something in main, because we don't need anything from main, because main is the main thing executed. So I'm going to talk about the visibility stuff. You guys will learn more about, if you go into CSE 205, you guys will work with these a lot more. CSE 205 is basically all about this stuff, about making classes and stuff like that. So public basically means that any class, or any class, which is basically any file outside of this one can access that variable. So like, or access that variable or function. So any class can use these functions because they're all public. So like I can, in a different folder, I can make a square, because remember, I have to call them, you guys have probably done this where you have like a main file that just has like your main in it, and then you'll have like another file that will have like all this stuff in it. But to use these functions from your main file, you have to create an object of it, right? You have to do something like this. So what that's doing is it's creating that box with these attributes. So like attribute 1 and attribute 2. So, but then what it also does is it has, this box also has all these helper methods in it. So if I want to call this function, I have to call it from this box. So let's say I named this box, I'll just go with my bad naming conventions. I'll just name it X. So to call this function, I need to call it from one of these boxes, which is like X dot add 1. So to answer your guys' questions about, someone asked what's the difference between these get methods and a set method. So a get method is actually, let me finish the visibility, because it will make more sense after I do the visibility. So public means I can access it anywhere outside of the file from one of these boxes. So that means that like if I create a box in a different file, like one of these boxes, so creating an object of this class, I can call any of the public functions. Protected basically is similar, but instead of any file outside this one, it's only files within the same folder. So like, let's say I have all these files in a folder. Protected can be called by any classes in the folder, but not any classes outside the folder. While public can do both. So, and like I said before, undeclared visibility defaults to protected. So like right here, this function right here is protected because it doesn't have any visibility. Like you didn't explicitly tell it the visibility, so it defaults to protected. And then private means it can only be used within this file. Like I cannot access these variables anywhere outside the file. Like if I have a private function, even if I create a box in another class, I cannot call that function from that box, because the only time I can use that function is within this file if it had the visibility of private. So the answer that whoever's question had it about why we need getters and setters is because if you think about it, these are variables right here are private, and that's the typical standard, that your attributes of a class will be private. So if I have a box of this class in another class, I can't access these attributes directly because they're private. So because if this box is in a different class, like a different file, I can't access them directly, because private means it can only be accessed in the file that it's created. So what getters and setters are like workarounds. So like if I want to just use attribute 1, if this is private, I have to make a getter for it. So what that does is that it allows me to use or to get attribute one, because remember this function is public, so I can use this function from outside this file. And what it does, it will give me that variable. So it's like a workaround. So it's like, since I can't access the variable directly, I need to make a function that will give me the variable. And that's the point of a getter, is to basically just give me the attributes, the private attributes, so I can use it in a different file. Because if I didn't have these getters like at all, if I didn't have like public int get attribute one, and if I didn't have these at all, I would have no way to get to know what these variables are out like in a file outside of this one. So and then what a setter does, so a getter, all it does is return it. It just gives me the value back. But what a setter does is it actually changes the value associated with it. So like this one doesn't change anything. It just gives it to me back in return. But like if I had like a setter, which I don't have an example in here, but let's say I had, keep in mind, setters typically had void return types, because we're not throwing anything back. We're just changing the values of attribute one and attribute two. So I'll type it out. I'm going to type out what it will look like because I don't want to draw it because my handwriting is really bad. So what it would look like a setter would look like, is like public void. I know you guys probably can't see this quite yet, but public void, set at one. And then, so getters don't have parameters because we don't need anything extra, because all it does is return attribute one. And we know that we can already get attribute one because it's one of those attributes of the class, because it's in, so remember I said you only need parameters if you need a little bit extra from something that's not in the class, like number for the case of here. Oops. I guess I can keep going with this, but like, oh, that's supposed to be public. I misspelled it. I'm sorry. So like a setter looks like something like this: public void set attribute one, and then inside the parameters is the actual value I want to change attribute one to be. So it needs the parameter needs to be the same type. So int, and I'm going to call it like at one, And then all the setter does is it says attribute one. So, oh gosh, I don't want to write that big word. Attribute, that's attribute, I swear. One equals at one. So what it does is so let's say I have this box, and we know that it has like every box of this class, so every object. So every time I say box, I'm talking about an object. So every object of this class will have two things: attribute one and attribute two. So let's say we have this box that has attribute one equals to 0 and attribute two equals to hello. But let's say that I want to change that 0 to be like 4. I can't just say like this box, because we know that, let's say this box name is, I'm going to be very creative. This box name is box. So we know like I can't access the variable directly by saying like box dot attribute one, because I can't access directly, because we're assuming that this part is outside this file. But since it's outside this file, I can't access it because it's private. But the function that I have right here is public. Oops, can I redo that? Okay, can I get rid of, oh my gosh. Okay, so this function up here is public. So instead of accessing it directly, because I can't say int attribute one equals something because attribute one's private. So the only time I could say attribute one equals something is in this file, but we're assuming that this box variable is outside the file. So if I want to set the variable from outside the file, I have to make a setter method like this that would be inside the file where the attribute is. So like in this file. And we would say box one dot set attribute, and I would give it the value I want to set it to. So like set 4. So what it would do is then it will go into this class and set the attribute here to 4. Classes and functions are very confusing, but if you don't really understand it that well now, I would not fray, because if you're taking CSE 205, you'll be hammered with this knowledge. Like this is all the class is basically all this stuff. So if you make a variable at the top public, can you manipulate? Yes, exactly. So if I, so the question is, if I make my attributes of the class, let me just erase all this. If I make my attributes of the class public, like if these were all public instead of private, I could actually access them directly. So I could say like box, oops. I could say like box dot attribute one equals something, because if they're public, I can do that. But if they're private, I have to use like a setter and a getter to work around it. So yes, if their attributes were public, I could access them directly, but if they're private, I cannot. Yeah, so then in that case, if I can access it directly and change it directly, I wouldn't need a setter and a getter method. The setter and getter methods are only needed if they're private. So why don't you ever make private? So think of it in like real world industry. The reason why it's standard to make things private is because, if I pretend I am a malicious user and I want to, try to hack into the system, let's say that these variables hold like very important information where I don't want anybody to change it. Or change it or view it. You would make them private, so only like the file that I have can access them directly. So it's more of a privacy thing. It's nothing that you guys will have to worry about now, but in like real world industry, it's used to just to encapsulate data so other people can't view it or change it. Because like, let's say that your bank account info, like the balance of your bank account was a public variable. Well, if you make a file that's able to just you just like send a file to it that just says like, oh, my bank account info, if I can access it directly, like the value of it directly, I can change it to like $1 million. Yeah, and that wouldn't be a good thing. So that's why they're kind of private, is just so you don't have to worry about security stuff. Yeah, I wouldn't see the problem either. So another question says, I know you mentioned that this presentation will be posted on YouTube link a few days ago. Can you post a link because I don't see it on the chat? Yeah, I posted it a couple times, but there's been a couple questions. Oh, that was a private message, but yeah. I'll post the link again as a public message. So just in case anybody wants to do that, it might take a couple days to be uploaded to this channel because they need to review it. But yeah, that would be the link that it's going to be posted at. So that's basically the end of the classes. We kind of just went over basics. I wouldn't worry too much about this now. I know it's kind of confusing when you first learn it, but in CSE 205, which I think most of you have to take, even if you're not computer science, you will be hammered home with this stuff. On your quizzes and tests, I doubt they'll go too extreme. Thanks, much cheers, no problem. So now this is the time to ask some questions. I can probably be here until 2. So feel free to ask questions. I can go back to previous slides. You can ask like theoretical questions. I can code something if you want, anything like that. Yeah, thank you guys for coming. I will still be around for, I'll wait a couple minutes, and if nobody has questions, I'll end the meeting. So if you have any questions, ask them now. Can you talk about super? Yeah, I'm surprised you guys talked about that so far. So, because that's with inheritance, which inheritance is all 205 stuff. So let's say that let's say I have a class called like student, but then let's say I want 2 different types of students. So like let's say this is the general student class. So, but let's say there's 2 different types of students. Let's say there's like an on-campus student. I'll say like on campus, and then let's say there's another one, which is online student. So we know that both of these are students, but they're different types of students. So let's say like an online student has like, a little bit different attributes. Like maybe they have like a different tuition fee. Like maybe like an on-campus student has like the actual building numbers that their classes are in, which, online students wouldn't have, but yet they're both students. So essentially what it means is that you're making, to describe what super means, I kind of have to describe what inheritance is. So basically what would happen is that, like, let's say a typical student has, like, you know, an ID, an ID, you know, like and a name. So what would happen in terms of inheritance is that both of these other things that I have, they'll inherit the attributes from the parent class. So the parent class in this case is student. So an on-campus student and an online student will also have an ID and a name, but an on-campus student could have, you know, oops, could have, like, let's say another attribute called like building, which is like, you know, maybe the list of all their buildings that they're in. Well, we know that, you know, an online student wouldn't have that. So let's say an online student has something, you know, slightly different. I don't know, what does something online students have? um, I'm trying to think of something that online students have that on-campus students don't. But let's say, okay, let's just call it, like, you know, let's say they have a different variable that, you know, only they have, but on-campus students don't. So they both have the parent class's attributes, but then they also have their own attribute, like a single attribute that they don't share. So what super does is that super is, if you call super from a child class, that's what accesses the parent class. So if I do super parentheses, essentially what you're doing is you're calling the constructor of the parent class. So the student constructor, which is what we, because, like, let's say we make a constructor for on-campus student. So you remember what a constructor does. All it does is it initializes all the variables. So we know for on-campus student, they have three variables. They have an ID and a name that they got from the student class and a building number. So the student constructor will have already, or the student class will have a super constructor, which will already initialize those variables. So what I would do is, in my on-campus student, I would just call, like, let's say my on-campus student, like, let's say we have a constructor for an on-campus student. So my constructor for it will call the super constructor because we need to initialize this student's ID and name, which are in the student class. And then all I would do is I would initialize the one that's not in the student class, which is building. So doing, like, the super parentheses is just getting access to the parent class from a child class. And in this case, it's calling the constructor. Does that make a little bit more sense? And again, this is like inheritance, because this has to do with inheritance. This will be all CSE 205 stuff. You will do a lot of inheritance. So if it's not as, you know, if it's not as clear now, it will be very clear at the end of next semester if you're taking 205 next semester. But does that make a little bit more sense, Catherine? And does anyone else have any other questions? And if it's anything small, I can even code it too, if you want to see how something works. I have a online compiler opened up somewhere else. So I'll give you guys, I know there's 9 of you left in here, everyone mostly left. So if any of you have any quick questions, be free to ask it now. If you don't ask it in maybe the next minute, a couple minutes or so, I will end the meeting. So now is the time. And again, if you just want me to go over like a couple slides again, something you didn't really get, maybe you want me to reword something, let me know. Do I have, where is it? Let me stop the screen share real quick. Where is, where did I, oh, okay, so let me show this. Could you show us a visibility works in actual Java code? Yeah, so, okay, it might take me a second. Here, let me pull up. I need to, oh crap, I can't do it here. Okay, I wouldn't be able to do it on an online compiler because I would need to show you the actual code. I mean, it might take a bit, so Let me see. Where can I just put this? Where can I throw this stuff? I will throw it here. Okay, here. I will just, I guess you guys can watch this part. It's not a big deal. So this is VS Code. This is what I use for coding. So I want to make, I'll make like a student class. Oh, am I searching for it? But I wanted to create a new one. File, new file. Yeah, okay. So save as, I mean, this is just my IDE, so don't worry too much about this. So I need to make 2 classes so I can show you. So I'll make that one, and I will also make, if you're typing the chat right now, I can't see it because I'm just setting this up. So give me a second if you said anything. So I'll just make this my main, like my main class. So again, public class main, and then since this is going to be my main, I'll put oops. Oh, I keep spelling everything wrong. String. You can let me, before I keep going, you guys can see this, right? Or am I just kind of assuming that you guys can see what I have? You guys can see this actual code that I have so far, right?
Yeah.
Oh, okay. Okay, so here's our main. I'm not going to put anything yet. I'll do my student class first. So again, it's called, my class is called, why did I do capital? It's called student, so I have to name it student. So public class student. So let's say it has, you know, an int ID and a string capital S, I think it is, string name. What happened? Oh, I forgot my semicolon. And then let's say, oh, let's make them private since we're talking about visibility. So then I have, let's say I'm not going to make a student constructor just to save some time, but I'll make some getters and setters. So like get ID. I mean, you can name it whatever you want. So I have to make it public. Then I don't need any parameters because I have all the information I need, because all I need to do is return. Oh, I forgot the return type. Public int get ID, return ID. And then public string get name, return name. So those are my getters, and then I'll make my setters. Public void, because I don't want to return anything, I'm just changing something. Set ID, so then I need to give it the number that is going to be the ID, and then ID equals num. So set name, same thing, but instead of an integer, it's going to be string. I have my chat opened up. String, and I'll show you guys this too. You guys will have the same thing. Is that if you notice, like I have this variable's name is the same as this one, so I can't say name equals name because your compiler will get confused which name is what. See how it's like kind of giving me a warning because it doesn't know like which name is this name and which name is that name because they're 2 different ones. So if I want to access this one, that's where that keyword this comes into play. Because if I say this dot name, it references the class name. But if I say just name, it's like I guess the closest name, which is this one. So I guess you can see that in action too. And I'll add like another, I'll add that add one method too. So it's like a result equals number plus 1. I forgot the type. Result. Okay. So this is my class. This is my student class. So now in my main, so again, to get all these functions, I can't just call like, oops, I go there. So I can't just call like get name, for two reasons. One, because if you call it just like this, it looks inside this folder for that function. I mean, there's no get name in this folder, so it's not going to know what it is. And also, like, what student am I getting the name from? We don't know what student. So to get access to basically this file, I need to create an object of it. So that's basically just doing student and then the name. I guess I'm gonna call it student1 equals new student. This is how you just create an object. And I'm gonna just call the default constructor. So now I have access to this file. Well, I have access to some things in this file. I have access to everything that's public. So let's say that I wanted to get the student's name, like that student's ID. So let's try to print it directly. So like student1 and then dot, and then, so as you notice, like my auto generator thing doesn't even find it because all it's looking for is the public methods. So like, as you can see, like I can't directly access the ID because it's private, but like, let's say I change this to public. Now I can, because now we can see it from here. Because remember, it's in private means if it's not in the same file, I can't see it. But public means I can see it pretty much anywhere. So that's why it has access to it there. But then if I change it back to private, it does not have access to it anymore. So the workaround is those getters and setters. So if I want to get the name, if it's private, I'll use the get ID associated with it. So like the get ID. So if I run it, yeah, see, the ID is 0 because I called the default constructor, which made it, since I don't have one, it uses the default values, which is 0. And then, so if I want to say, pretty much then basically I can do that for pretty much anything in here that has the word public, I can use it. So I can use this get ID, I can use this get name, the set ID, set name. But let's say I had, let's make a private function, like private, I'm trying to think of what even to do. Let's say private, let's say void, I'm gonna say like print name. Let's say something like this. I have print name. And again, I don't need anything in the parameters because I have direct access to the name because it's up here. So then let's say this function, all it does is it prints out the name. So yeah, whatever. So like if I wanted to print the name from here, so I say like student1 dot, you say like my auto generated thing doesn't even find it because it's private. So when you're trying to use it from the other class, like since it's private, I could only use it within here. So like, let's say that, let's say after I set the name, I want to print it. So since it's in the same class, I can call it directly now. And I don't need to do something dot something because it's in the same class. So I don't need to call it from an object of the class because it's in this class. So I could say this dot name equals name, and then I could use the print function from in here because even though it's private, I'm still in the same file, so I can access it. So then if I call like, if I say student1 dot set name and I give it, I don't know, my name. So it should print out, so let's change the student's ID. Student1 dot ID, or so set ID, because that's how I change it. It's using the set method since I can't just do student1 dot ID because it's private. And I'll give it, let's say, number 12, first number I thought of. So what it should do is set the number to 12, and then it should print out 12, and then set name. And then set name has a print statement in it, so it should print out the name Alec afterwards. So let's run it. Yeah, so it did. It printed out 12 and Alec. I guess I could have just done a, yeah, I guess I could have just done here. There we go. So yeah, 12 and then Alec. So I was still able to use that that print name function, but I couldn't use it in here because it's private. but I could use it from here because I'm still in the same folder. So I could, you know, if I wanted to change the name and then print the name, I could do something like this. And then for protected, it would basically, in this case, like if I change all these to protected, it would still work. Because remember what I said, protected is in the same folder. Well, they're all in this same project one folder. So I could still access it. So in this case, and it's very rare that, so you'll use protected when you use inheritance. And that's for its own like safety reasons. When you'll get more and more about that when you get into 205. But it basically means that stuff inside this folder can view it. Public means even outside this folder can use it, and then public is anywhere, protected this folder, private just that file. I hope that helped. Is there anything you wanted me to like do with this afterwards? See, typically this is how the code will look, is like you'll have just like one class with just like the main function, and then basically everything else, like I didn't have any, like this class doesn't have any attributes with it, which in most cases it won't, because this is, you probably have heard that word, like the driver program. It's like this is what you use to like test to make sure all your code in here works. So main is like, you know, the driver program, which just runs the code that you made in like the other files. And it can do some things itself, but it shouldn't have like a lot of it. Normally your main file won't have like attributes in here too. So yeah. Cool. Any other questions? Any thing you guys want me to do with this real quick? I'll probably stay till 2. So technically an hour after it was supposed to be done. But anything to help you guys. If you guys have not checked out the tutoring center, because that's where I work, I recommend going there. It's very helpful. We're really good at, because I know sometimes professors forget, like they'll use like high level like terminology that'll get kind of confusing. So we're pretty good at like putting things in the layman's terms. We can't help with any like tests or quizzes or anything, but we can help like debug homework and stuff like that, and you know, give another refresher on like general knowledge stuff. So we're just an extra resource to use. So don't forget about us. Oops. Any other questions? Last chance. I'll go over pretty much anything. This won't be uploaded on Canvas because I'm not like a TA or anything for you guys. It'll be uploaded to our YouTube channel, which I think I posted the link a little bit earlier in chat. Yeah. Yeah. If you scroll up like 4 or 5 messages ago, I have the YouTube link. I'll just repost it. It'll be posted here after like a couple days. It should be, at least. I hope it is. That's out of my control. But yeah. So yeah, if the people that weren't able to attend, like, you know, if you had any friends or anything that wanted to attend, they couldn't, just, you could give them this link and then they could keep their eye out for that video. Yeah, no problem. I'm probably gonna be ending the meeting now. So if you have any last questions, right now is the time to ask, or I'll probably be ending it within like 30 seconds. If you have a question and it may be a long one to type out, just type wait in the chat and I'll wait. So I'll just wait a couple more seconds, maybe like 30 seconds. Yep, and if you guys don't have any questions, I will end the meeting and then I'll send this video off. All right, I don't think there's any questions. So if you guys do have any like follow-up questions, I mean, you could email me. If it's like a long, more open-ended question, it will be hard for me to get back to it. But if you have more like CS questions, I just recommend going to the tutoring center. You know, you might be able to catch me, and there's a lot of other great, useful people there as well. And typically, you don't have to wait very long for help. We're not that busy, especially due to everything being online. So if you have any more questions, I just recommend not emailing me because it might take me a while to get back to it. Just you can just go to the tutoring center's website. I think it's pretty easy to find if you just go to like the search part of my ASU and just type in like, you know, FSC tutoring center. It'll probably just take you to the link right to our website. And then it's pretty straightforward to follow from there. So yeah, if you have any questions, just go there. You might be able to catch me. There's also a schedule there. So you might be able to find the times that I work, and then you can come in during that time and ask any follow-up questions. But yeah, well, I wish you guys the best of luck. Thanks for coming, guys.